Okay, sample problem. Very similar to one of the problems I showed you in the pre-lesson with slight differences. So it says, consider this polynomial equation, make a table of values. And they don't even give you this. So rule number one, use these values when they ask you to make a table of values to identify the key features. Now, we don't need the graph or anything to figure out the leading coefficient. This is the highest power, so that's a 1, so that'd be a 1. And it's also positive, which we'll just throw that in there. It's implied by writing the number 1, but it is significant. The degree is the highest power, which is 5. Okay, it's odd, which tells us something. And now we got to get into the graph to really understand the end behavior. Now, if we know the rules, if the leading coefficient is positive and it's an odd, we could answer this right now just by memory, but I'm going to pause, get the graph, because it does say sketch the graph, and then we'll really be able to wrap our brains around this. All right, so I'm going to demonstrate one of these, but this is what you're expected to do. So if I was to take -3 and plug it in here, I get -3 to the 5th power plus 18 times -3 squared plus 10 times -3 plus 1. Pause. So as you can see, I did my work. So I raised -3 to the 5th power, got this. -3 squared is 9, 9 times 18 is this, 10 times -3 is this, and then 1, I got -110. Now I'm not going to bore you by showing you all my work. I'm just going to pause this and fill these in. And so there, got them all filled in. You can see some of the numbers are huge. That tells me a few things. The first thing it tells me is I better be careful on my graph. I can't go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So I can see that my x's, are normal. My y's get massive. So I'm just going to go like this, 2, 4, 6, 8, and I think this is what the book does, 2, 4, 6, 8, but then it jumps up in 10, so 10, 20, 30, 40, and as you can see, I'm not going to get up to 110. We're going to kind of get a good estimate because it says sketch. So don't worry about these massive numbers so much. 436, I don't think so. So we're going to get the sketch right. To get the general idea. Now we got to be detectives and kind of look at this pattern. And this is what they want us to do. Fill in the table, build a graph that's appropriate, and then look at it. So notice from here to here, make a teacher thingy, is increasing. Now from here all the way to here is decreasing, but then it starts from 1 to 30 and it just keeps increasing. So what that's looking like is that there's 3 bumps. Now remember, there's a little confusion there because with 5 there's going to be 4 bumps. But we're just not going to be able to be that precise about it. So that's why it says sketch. Relax a little, breathe. And so now we know from here to here, it's going to be increasing, decreasing here and here. Now what I'm going to do is, generally speaking, plot these points. So 0, 1 would be barely above the x-axis. 130 would be right about here. And 225, who knows? So that's just going way up. And then it just keeps going up and up and up and up and up and up and up. So we know that. So it's increasing from here to here. So we just know it's going to go up and up and up and up and up and up. Perfect drawing? No, 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 no. Now we're going to keep going. -1, 8. So there's 2, 4, 6, 8, 2, negative, -4, -6, -8. -1, 8 would be right here and maybe right here. And -2, 21 would be right about there. And it's decreasing all the way between these 3 points here. So 1, 2, 3. I know I can go like this. It looks like there's a turning point there. And then it's increasing from -3, -110. So -3, -110 would be way down here. It's going to be increasing from there to there. Perfect drawing? No way. But we got a general idea of what's happening. So what's the end behavior? Well, as x, your roller coaster, no matter where you start, if you're moving left, so you're going to go like this, and the end behavior is going to be down, so it's negative infinity. We change the direction and go to the right. Where are we going? Up, forever. So that'd be infinity. So that's part of what they're asking for. And the final part of this problem, they're then going to ask you what's the rate of change. This should be a review question. So remember, this is your domain. This is just from 0, including 0. So that's saying, hey, from where x is 0, which by the way is 0, 1. So that's the point 0, 1. That's what this is telling you. From that point to where x is 2. And when x is 2, we look at our chart, 125. That's a fancy way of just saying from this point to this point to 125, find the slope. Where's my x1, y1? Here's my x2, y2. If I plug it into the good old slope formula, I should get her done. So y2 is 125, y1 is 1, x2 is 2 minus x1 is 0. So what do I get here? I get 124 all over 2, which is 62. Now that's my slope. It's really 62 over 1. So that means from here, I have to go up 62 over, or up 62 over 1, up 62 over 1 if my drawing was perfect. All right. Okay, final example. In your example problems, they're just going to give you a bunch of clues, and they're going to ask you to sketch it. So the breakdown I gave you during the pre-lesson was, start with this. Where are things positive? Where are things negative? Where are things above the x-axis? Where are things below the x-axis? If we get started there, we'll be good. From the interval -2 to -1, so from -2 to -1, it's positive. Now how high? We don't know, okay? But goes up and comes down. 1, 2. There's my 1, there's my 2. It's going to be more of the same. I'm going to get crazy, make it bigger. Is that accurate? No, that's why it says sketch, okay? But now it's negative, different color, just to break it up. From negative infinity, that means all the way this way, all the way to -2, it's negative. So that means it's below the x-axis. Maybe it's coming in like that. Accurate? No. Also, from -1, from here to 1. So that means it's got to go, you can kind of see the pattern. It's going to go like this. And it's also negative from 2 all the way to infinity. So that just means it keeps going like this. All right. So there's a sketch. Now, let me pause this a second. All right. I just want to make sure I wrote my numbers down right, and I did. So it's saying increasing from negative infinity to -1.5. So it's saying if you go all the way, start way over here on the graph. Remember, increasing, decreasing language means you got to move on your roller coaster left to right. You just have to know that when they're asking you questions about increasing and decreasing. So here's my roller coaster. Little ride, I got to move left to right. It says it's going to be going up from here all the way to -1.5. Now notice this is -1.5. So right there is a turning point at 1.5, where x equals 1.5. My drawing just kind of naturally does that. And it just kind of will too, if you get the general idea from these two clues first. And then it's also saying that it's increasing from 0 to 1.5. So increasing all the way to there. That is all increase. It's also saying it's increasing from 0. So that means where x is 0. So that means right here, all the way to 1.5. And as you can see, it's going up. So these two sections right here, it's increasing. It looks like my first drawing kind of captured that. And now it's decreasing from negative 1.5, that means from here, oh, that's negative, and to 0. And as you can see, that's down. If my roller coaster's between this section, I'm going down. Same thing goes from 1.5 to infinity. So here's 1.5, so x equals 1.5. So if my roller coaster was right here, this portion of the ride, from 1.5 to infinity, it'd be going down. So I'll make that all purple, okay? So on my first attempt, I kind of locked in these clues too. It just kind of happens.